Thanks very much for giving that. If anyone has more feedback later, I'm going to be around for the day, so I'd love to hear and talk to you more about that.
Thank you. And is this on? Yeah. Our next speaker is William Stein. He's installing his presentation right now. He's a professor of mathematics at the University of Washington. He also has a blog, I just found out, the Sage blog. He's getting his mic together. This talk is called Sage Notebooks, and
all right, thank you.
And he's ready.
So I'm going to, instead of giving a talk on the Sage notebook, I'm going to give more of an overview talk about browser-based notebook interfaces to mathematical software. The Sage notebook is one of them, so I'll be able to give a short demo of that during the talk, but I'll talk a little more broadly than just that. Here's an old mathematical notebook, by the way, one of my favorites. It's Gauss counting prime numbers, and it's his actual notebook. So the talk will be divided into 3 parts: the past, the present, and the future. So the first web-based calculator, at least that I was involved in, that I knew about, is the Magma Calculator. Magma is a computer algebra system aimed at research mathematics, pure mathematics. It has essentially no numerical functionality at all, but it has extremely advanced functionality and symbolic computation in the sense of abstract algebra, algebraic geometry, arithmetic geometry, and so on. This is the actual version that's running right now in Sydney. The version I wrote in 2003 was slightly different. They changed the style somewhat and rewrote it, but it's pretty similar. I wrote it in 2003 so that students in a class could have easy access to Magma. In 2006, we found out about something called Ajax that was being used in Gmail, and we wrote the first web-based interface to Sage. And you can see it right here. This is a picture of it. Notice that there's no, well, it's kind of hard to see because it's small, but there's no login. I'll just tell you some funny things about this. First, it was an extremely difficult program to write at the time because the support for using the sort of modern JavaScript style approach to web programming wasn't so good in January of 2006. It was pretty painful. I just heard of Ajax, and one student had some idea of how to get it to work, but if you wanted it to work in several different browsers, it was very painful. Just selecting elements, jQuery was just barely starting then, and so on. So it was pretty painful. But we did write this notebook interface. You would go to a certain website and use it, and it just had a list of all worksheets that anyone had made, and you just click on one of them, and you get a worksheet, and you could start interacting. You could work. It was just complete sort of public Scratch place. So you would typically name a worksheet with your name, and then the contents. But it was useful for certain things. One of the students, Alex Klimashaw, that helped me a lot with writing this first notebook, moved back to San Diego, and he started writing something called CodeNode, which you can see right here. This is their website. He worked a lot on it from 2007 through 2009, but unfortunately had to work another full-time job, so he stopped working on it then, and nobody else really picked up on the project. One thing I think we learned from this was that he had hoped to get a lot of the users of the Sage notebook to switch to using this, but there's like this big list of features that we had accumulated in the Sage notebook, and I'll show you what some of those are in a minute. And it's really hard to switch from having those to not having them. And then they turn out to be harder to implement than you might think. So you think, oh, I'll just do one of those a day, but then when you try it, it turns out to be harder than that. The second version of the Sage notebook we wrote in 2007. So this was written, most of it in the course of about 3 weeks. 1 week, 5 students and I worked at a Sage Days workshop. And then the last 2 weeks, me and one other student, Bobby Moretti, worked a lot on this. And we used it initially for a high school program on called SimUW that worked out pretty well. It was very much inspired by, I don't know, Google Docs kind of style. It's really a lot like, it kind of felt a lot like Google Docs did in 2007, except instead of word processing and spreadsheets, you had a mathematical worksheet. But otherwise, it had a similar feel. For example, you had individual user accounts, and it had a lot of features not all of which we implemented then, but got added on over the following year or two by people who were interested in using it. But one problem, I mean, at the front, when you look at it, it looked a lot like, say, Google Docs, but the back end was dramatically different, of course, and far less scalable. This was mainly aimed initially at having one user, and instead of writing a graphical user interface on the desktop for Sage, like you would have with MATLAB or Mathematica or whatever, we decided to write a web interface just because you have, you can scale your fonts easily, you can change your fonts. There's a lot of things you can do in a web browser that are very painful to implement on a desktop, and it just seemed like it would be easier to do it that way. So we designed the backend just aimed at one user. People who are working on IPython notebook will know that that's a good place to start. It's very natural to get that working well first, but it's only a very small part of the picture, but it's a very visible part. So there are a lot of notebook-oriented, or a lot of math-oriented features, so typesetting and mathematics, interacts. So this was something, I'll show you a demo in a second, but it's kind of like what, well, basically it's a quick and easy way to make a graphical interface to some function that you've implemented. So if you want to make a bunch of widgets that allow you to drag a slider and enter something and then see some output, then this makes it very easy to do in a web browser. And I'll show you an example of this momentarily. I implemented this at a Sage Days workshop that Enthought sponsored in Texas, and then it got improved a lot by other people. But it took quite a while to implement all this stuff. And actually, let me give you a quick demo of the Sage Notebook, since that was sort of promised as the talk in the title. So I'll move out of full screen mode. There it is. Okay, so this is the Sage Notebook in the current version of Sage. I've already logged in and created a worksheet, and you can do things like make a function. You can integrate the function. And behind the scenes, by the way, that's using, this is Sage, and behind the scenes I use Maxima to compute that integral. If you type show of the function, then it typesets the object, whatever it is, could be a matrix, power series, whatever. The typesetting is done using MathJax, which is this JavaScript library that was just mentioned moments earlier, whose development was funded by many institutions, like maybe the MAA, AMS, and so on. And so what's being typeset is that. But you can see how this is a notebook interface. You can insert new cells, etc. Change cells that you've already entered, reevaluate things, and so on. You can get help. A little, like if you type function name question mark and hit the tab key, then you get help. It's nicely displayed using Sphinx, etc. You can also run, there are a whole bunch of languages that are supported in the notebook interface. So there's a long list at the top of the worksheet, but some of them include Gap, Perry, Maxima, Octave, MATLAB, Mathematica, and so on, and R is also one of the languages. So you can enter blocks of R code. Oops, oh, I've overridden the variable R, so let me reset that. I used it in some 3D graphics thing elsewhere. But you can type R code in. You just put %R at the beginning of the cell, and then the rest of the cell is evaluated using R. You can also set the notebook or that particular worksheet to be in a mode where all code by default gets evaluated in R. And if you want to switch to Sage, then you put %Sage in the cell. You can also define variables in R and get at them from Sage and vice versa. It's one of the core features of Sage is being able to interact with persistent sessions of other computer algebra systems. And I think almost every math software system is supported for doing that. Here's a very simple example of an interact. This is a completely silly, contrived one. So you just specify a function and some default values. And based on the default values, it creates controls. So for example, an iterator, it gives you a list. It gives you a range slider, or just a slider. If you give it a color selector, it gives you a color selector, etc. There's also things like 3D plotting that you have embedded inside the notebook, which is an enormous headache. This is difficult mainly because it's downloading right now we use a Java applet. This is the only place in which Java is used at all in Sage, but it's used to display interactive 3D graphics. So First, it actually renders it using some sort of Java in the background statically, but you can click Make It Dynamic, and it will start a Java applet, which looks pretty good. It doesn't require any 3D acceleration. It works pretty well for this sort of the complexity of graphics we're displaying here. Oh, there it is. It just took a little longer. So there's an example. This is an implicit 3D plot. And the code that draws this implicit 3D plot, by the way, was implemented mostly by a freshman undergrad at UW from scratch. So it samples a function at a lot of points and then figures out what the surface is that goes through them. So that's just part of Sage. Okay, so that's a quick demo of the Sage notebook. And now I'll switch back to the main talk. Okay, the present. There's a public Sage notebook server called sagenv.org that I run. It runs on a single computer that the National Science Foundation bought me in 2008. So it is a computer from 2008. The computer has 24 cores and 128 gigabytes of RAM, so it's pretty good for a 2008 computer. And it would work fine if there were only a few hundred people that use the Sage notebook. But unfortunately, it has 110,000 accounts, and it gets completely slammed regularly. So at certain times of the day, suddenly a lot of people want to use it, and it just becomes useless. So that's the situation with this website. I haven't got another grant to update this hardware yet, but it's, I don't know. It is true, though, that a server does last for more than 3 years, as you can see. One thing is that the software we're using to run sagenv.org, that website, is exactly identical to the software that you get when you install any copy of Sage. Any download of Sage has exactly the same server software. That server is just started up by typing notebook with some options. Another separate project, which has had a lot of development during the last year, is called the Sage Cell Server. This is a website, and I'm just showing you the website in a little iframe right here, where you can type in a single calculation. You can type in a single calculation. I mean, this is just a silly one. And it will evaluate that one input and then show you the output. The code editor is really nice. It uses code mirror, so it's syntax highlighted and so on. The output, it appears as it's being computed. You can get a permalink or a shortened temporary link to that output, or to this whole this whole single computation. So if you have one single calculation and you want to share it with somebody, you can do it, make sure it works here, and then get a shortened link and then share that with other people. And there's a database of these shared interacts on this website, interact.sagemath.org. It's the sort of thing where you can rate other people's. There's a page that you fill in order to share your own interacts, etc. Here's an example called visualizing the hop vibration, which I'll just show you. So what you find when you click in this website, interact.sagemath.org, you'll find lots of little text areas, which in your browser you can just evaluate right there. And you can also take these exact text areas and embed them in your own website. I'll show you an example of that in a second. This particular one is kind of interesting. Notice that the way the actual code works, it's something that's a little bit more complicated than what you'd want to put in just one cell. So what Jason did in this particular case, he wrote this one, or actually, Jason put it up here, and I guess Niles Johnson wrote it. But he took the code, the more complicated code, put it on GitHub, and some of the code is written in Python and some in Sage. And in Sage, you can just say load and give a file name. So if it's a Python file, it'll compile it on the fly for you. And if it's a Sage file, it just loads it. And these are being loaded off of the web. So when I click evaluate, it turns the Python code into C code, compiles the C code into a shared object library, links that into the running copy of Sage, and then runs it. And the point of Python is to provide something like Python, but much, much faster. And so you can drag these sliders and change the size, and you get an image of the hop vibration. And there, yes? yeah, I don't know if this is using it, but yeah. So it may be an option. I haven't looked at this in great detail, but definitely the Sage Cell Server fully supports Interact, 3D output, everything that Sage supports. Except you can't do tab completion in the cell because you haven't evaluated any code, so it kind of doesn't know what things are. And it's not very aggressive about doing that. Actually, right before I do more, let me just show you Rob Beezer's website, because it has various of these interacts embedded right in his web page. And it's kind of nice to see how you can do that. He's not that guy. He might be the... So, see, this is just his homepage, but exactly these code mirror cells where you can evaluate code using Sage and have arbitrarily complicated output appearing. So, like here, this is in his website. So you can change the numbers here, whatever you want. Yep. Command lines aren't necessarily malicious, but you can certainly edit. You can put, I don't know, let's see, it says edit me, so os.system ls-l/. Maybe I have to do popen. Not sure how they're getting output. So, yep, you can, but who's to say that's malicious? Yeah, well, that will remove the things that that user has access to. So I'll say some things about maliciousness in a moment. So there's also the IPython notebook, another current notebook. It's very integrated into IPython in the sense that if you go look around and try to figure out how to install IPython, you probably already have it installed. I mean, the IPython notebook, you probably already have it installed. It's included in most, I don't know when you guys started including it with IPython, but it's not a year ago. So if you've installed IPython last year, you already installed the IPython notebook. You might not have some of the dependencies, but that's just a matter of easy installing a few things into Python. And then you just say IPython notebook, and boom, there it is. And I'm sure you'll show them that in your talk. It's very good at supporting one local user well, and it it takes advantage of some features that are really nice. For example, it uses WebSockets, which gives you very fast communication between the client and the server in both directions. And the server can push stuff out. If you want to send a little message that's 1 character long, you don't have to send kilobytes of headers. It's really, really awesome. And the Sage Notebook doesn't take advantage of WebSockets because we wrote most of it about 5 years ago, and WebSockets wasn't, I don't know if it existed or it's changed a lot since then. It's come and gone. It's much better now. It's really awesome now. There's an online way to access the IPython notebook by going to wakari.io, which is something set up by Travis Oliphant, who was here yesterday. Oh yeah, because Wakari, you have to get like a beta trial to use it, and it sounds like they'll set you up if you want to try it out. Excellent. There'll be a white lightning talk demo. Very good. So, so not only is it for one local user, but you can also get it over the web. Here's a quote I found on the IPython Git page, which was that somebody was asking about OurStudio versus IPython, and according to Brian, there's a huge philosophical difference between the user interfaces of these two systems. One has a bunch of panes, and the other has a very linear input-output sort of style. And then Fernando is very excited about an awesome $1.2 million grant that they got yesterday for IPython development, so I'm sure you'll hear more about that in the next talk. By the way, speaking of R, there's something called OurStudio Server. So OurStudio, I think, is mainly a desktop application, but there's also a web-based version which looks very similar to the desktop application. Very, very similar. To show you how similar, here's some screenshots. So, hard to believe that's a web application, but I don't know. There exists something called OurStudio server. That's all I'm going to say, because I'm not super familiar with it. There you are. You'll see more on Friday. Oh, sorry. Also, somebody in this room wrote something which is an R-based notebook, and he only has a demo up right now. But what you can do is you can type some code in, and then you hit Control-Shift-H. So I'm just going to add 2 and 2, and it evaluates it and shows you the output over here very nicely. So on one side you have a bunch of input, and on the other side you have a bunch of output. Mathematica also is apparently, they have some sort of mysterious online notebook, but I've never actually seen what it looks like. Here is their website about it. So it's Wolfram Mathematica Online, introducing a new kind of technology. So after 25 years, it's very melodramatic and exciting, apparently. And you can spread the word, but unfortunately you can't actually find out anything. But they've but it should be pretty good. I mean, it's going to happen. What? Yeah, it's math. I mean, the icon pretty much says it all. So I'm excitedly waiting. I did apply for a beta version, but I was denied, I guess. But I mean, you can spread the word, and people are excited about it. So I'm not sure if they're just going to try to have something that looks exactly like Mathematica. I'm kind of curious how much they'll charge so that they don't undercut their sales of Mathematica itself, and how it will relate to Wolfram Alpha. Is there a beta demo yet or anything, or is it just like... Okay. Okay, I didn't know about that at all. Have you tried it? Cool. And it was a lot like MATLAB. Was it exactly like, what part of MATLAB was it like? With all the different windows and, okay. Cool. Uh-huh. Right. Yeah, that makes sense. Yeah. Okay, and also, I just want to say there's a whole bunch, there's probably hundreds of these online coding environments, like Cloud9.io, which is built around the ACE editor that I think the Mozilla Foundation's involved with. It's very nice, mature at this point. I mean, you log in, you connect. Basically, you log in, and then you say, I'd like to work with this GitHub repository. And it copies all the files over into a Unix shell, gives you an actual Unix shell account plus a nice editor, lets you edit the files, save them, and I don't know, commit them back to your GitHub repository, and run things. You can run Emacs and VI in the shell, etc. So it's pretty neat what they're doing. And they've designed it so that you can collaborate with other people very interactively. So that's neat, and there's many, many other things kind of like this for working with code online. As far as I can tell, none of them are really notebook-like style interfaces. They're really kind of much more inspired by IDEs, like traditional desktop IDEs, and they're much more aimed at software development rather than interactively playing around with mathematics. But it's super popular right now. Okay, the future. What I'm going to spend the last few minutes of my talk on is just a quick wish list. It's like 3 slides, listing what I'd hope for in the ultimate online mathematical notebook system. And I've gleaned this wish list based on making a list of some of the features that I like a lot in the Sage Notebook already, looking at a list of feature requests for IPython, and just things I wish were there. And I've just heard a lot of people request over the years. And more or less every single thing I'm going to suggest is available somewhere, possibly in some sort of program somewhere. It's just that it's not all in one nice unified place, which is a lot like how Sage was when I started it. So under graphics and visualization, it'd be really nice to have good 3D visualization in a browser based on WebGL, especially based on 3JS, so it'd have a canvas 2D fallback for devices that don't work with WebGL. 3JS is pretty neat, but if you want to really do mathematics visualization, it's a pretty painful process still. to just kind of drop it in and have it work well. There's a lot of subtle issues that come up. And using Java, which is what we've been doing in Sage, is, I don't think, a good long-term solution. It's like Apple's latest Java update just deleted Java plugins from your browser. So, I mean, if you're an Apple user, it's not the most immediately available thing. I tried to download it under Apple this morning. It was 50 megs to download a Java plugin, and it was going to take 1 hour in the hotel. So plugins are not the way to go. 2D graphics in the browser, it would be nice to have really good interactive 2D graphics based on SVGs probably. SVGs are nice because each graphics element is a real element, and browsers now support SVG really, really well. It's definitely not the case a few years ago, but now it is. And then editors for lots of different mathematical objects. There can be lots of different sort of JavaScript projects that you find on some hosting site that would all get integrated into one single mathematical notebook interface. So for example, if you have a graph in the sense of vertices and edges, it would be nice to be able to drag around the vertices and try various layout modes. There is a graph editor that Rado Kirov wrote. He it was working well in Sage for many years, and I tried it today in the latest version of Sage, and it just doesn't it doesn't work. I don't know why, but I think it has something to do with him working full-time at Google, and it apparently isn't his 20% project. I don't know what it is. So if you can bug him, that would be nice. He works with you in Mountain View. But it would be nice to have other editors for kind of lots of different mathematical objects. A spreadsheet mode, but beyond just, I mean, spreadsheets are limited often in what sort of functions you can write in the spreadsheet language. It would be nice if you could write arbitrarily complicated functions that use code from Python in your spreadsheet. And I can really understand the value of spreadsheets, but it'd be nice to be able to do a lot more. Scalability, it would be nice if our online notebooks could scale to having around 100,000 simultaneous users. I mean, if you think about the number of math undergrads that are likely to use stuff at the same time, that's a good number to shoot for. That does obviously require buying a little bit of hardware or renting it. It's actually pretty useful to have integrated chat right in your notebook. I've discovered that, like, I was teaching a high school class this summer and having the students do various exercises involving public key cryptography, and it would be really good if the chat, I had them try to chat over Gmail chat, and I had them try to do it over IRC, and it got really hard because they were using lots of random different chat systems. They actually didn't all agree on, most people didn't have sort of, like, a person would turn to the person next to him and they didn't have a common way to chat, which I was really surprised by. Like, one used Facebook and the other one used Gmail, but not, it was like that a lot. Yeah? No, text chat. Especially with math typesetting built in. And it would be nice if it's built into the system so that the teacher can for sure monitor what's going on. Homework grading would be good to have when you're teaching, and it would be nice if you can use the full power of whatever math software system you're using in your teaching to make your homework problems, to grade your homework problems, etc., instead of having to use Perl or whatever else. One thing that I've had many people approach me about is a feature where you simply have infinite uptime for particular calculations. So you want to start, this seems to be really big with combinatorics researchers. They want to start a calculation and be guaranteed that it will continue running for a year. I'm not like that at all, but there are people like this, there are a lot of people like this, and you could do it by snapshotting a virtual machine. Anyone can do it, but it'd be nice to make that really, really easy for users. And that's not the sort of thing you've seen in notebook interfaces, but why not? And then publishing interactive books so that they have sophisticated math behind them. This is the last page. Interacts, like I already showed you. Really good equations. MathJax already totally solves this problem. Beautiful typesetting. But what about a WYSIWYG equation editor? Some people don't know LaTeX, and they still want to input formulas that look great. Let's make it easy for them. The guy who wrote MathJax made a somewhat nice equation editor, but he didn't finish it. And it'd be nice if that were to happen. Everything should work on Android and iOS. I like to use this phone more than I use my computer, so it would be nice. I usually want things to work there first. I think it's really good if multiple people or multiple browsers can edit the same worksheet at the same time. Just like in Google Docs spreadsheet. You see it, you change a number in one cell and it changes in all the other ones. You can definitely do that if you're very careful about what it means for a worksheet to change, and you use WebSockets so that you can push events out. I've done nice stuff like this for myself. And I think I'll just stop at that point. Oh, well, here's some power user things, but like a full VT100 terminal, good VI and Emacs support, be able to easily run your code on 1024 cores, etc. So thank you.
Okay, yes.
Have you looked at Future Grid for?
What is it called?
Future Grid. It's
Future
NSF
Grid?
Funded,
Never heard of it.
It's NSF funded cyber infrastructure for running on the cloud. So if you can build an EC2 virtual machine, then you can apply for an account with them, and they can just give you time and dedicated hosting. And they've got funding for 1 more year. It's been extended. And
How much time and how much do they give you?
you just ask for it. I mean, a small cloud allocation is hundreds of thousands of core hours. So you start from there, and if you're demonstrating, then they can expand or they can ask NSF for more money.
Cool. That's good.
Any other questions?